Hello and welcome back to Chemistry Talk. I'm Hunter and today we'll be discussing how to calculate the molecular mass, the molar mass, or the formula mass of a compound. So I will discuss in another video what a mole is and how you calculate moles, but if you're already aware of that, today we'll be learning how to calculate 1 mole of a substance, or the molar mass. So our first example is water here. Water has the formula of H2O. I was nice here and I gave you all the formulas, but on an exam you might have to write them yourself. The first step is to identify the molar mass of each element in the compound. So here we have hydrogen and oxygen. If you look at your periodic table, you would see that, and I'm going to round to a certain extent here, just follow what rounding rules your instructor gives you, but here I'm going to say that water has a molar mass of 1.00 grams, and oxygen has a molar mass of 16.0 grams. Now, you got to remember about your significant figures here, because here you have 3, and here you have 3. So your answer should have 3 significant figures. So your answer here is 18.0 grams. Why? 2 times 1 is just 2, plus 16 is 18 grams. So that's how we calculated that. So that's the molar mass of water, and it has 3 sig figs. So we're good. Moving along. We have our next example, which is sucrose, C12H22O11. So a new element here, we have carbon, and carbon has a molar mass of 12.0 grams. We just said hydrogen is 1.00 grams, and oxygen is 16.00 grams. So you do the following: 12 times 12, actually, plus 22 times 1 for hydrogen, plus 11 times 16. So 12 is the molar mass of carbon, and there's 12 atoms of carbon in sucrose. 22 is the amount of atoms of hydrogen in sucrose, and 1's the molar mass. And 11 is the amount of atoms in sucrose, and 16 is the molar mass. So you find the mass to be 29.0 grams. 3 significant figures. Alright, so a little bit more involved, but nothing too bad. And then we get compounds like this, ferrous ammonia sulfate. So this is quite a monster. It may look, but it's not that bad. So step, identify the elements involved. Nitrogen, we know, has a molar mass of 14.00 grams. Hydrogen we've already dealt with, 1.00 grams. Iron is a new one, and that is going to be 55.8 grams. Sulfur is a new one, and that's going to be 32.01 grams. And oxygen we've dealt with is 16.0 grams. So we need to do our math here and find out how many of each element we have, how many atoms of each element we have in the compound. So nitrogen, you can see there's 2 ammonia atoms, and each one has 2. So this is going to be times 2. Then you can see hydrogen, there is 4 in ammonia, and there's 2 ammonia, so that's 8. Then you will see we have 1 iron, so that's just 1. And then we have 2 sulfur, because there's 2 sulfate. And we have 8 oxygen, because we have 2 sulfate, and each one has 4. So our molar mass here is 284 grams. Notice the significant figures, 3 sig figs, because our least amount has 3, but nitrogen has 4. Okay, so this is a hydrate. If you haven't learned about hydrates yet, you will. There's a lot of math we can do with them. But the hydrate's just a solid that has been hydrated that has a water attached to it. So it may look confusing, but it's the same steps. Identify your elements. So calcium has a molar mass of 40.01 grams. and I'm not going to write out the rest anymore because I've written that already, but when you calculate the amount of atoms and you multiply it by their mass, you get 172 grams, 3 sig figs. So this is pretty straightforward. You know, it's just math and calculating. But this one, our next one, our last one, turquoise, it's a little bit more involved. It has a lot going on. So this one I'm going to, write out the whole thing. First, let's choose a different color here. We have copper, and that has a molar mass of 63.5 grams. We also have aluminum, 27.0 grams. We have oxygen, 16.0 grams. We have phosphorus, 31.0 grams. We have oxygen, 16.0 grams. And we have hydrogen, 1.0 grams. So we have 1 copper. We have 6 aluminum. We have 4 phosphorus, because each phosphate has 1, and there's 4 of them. We have 16 oxygen in the phosphate, but we also have 8 in hydroxide, and we also have 4 in water. So you got to add those up. Then we also have 8 hydrogen in the hydroxide, and we have 8 in the water. And I just noticed I put oxygen twice, so let me erase that. So when you calculate that molar mass and you put it to 3 sig figs, you get 814 grams. So these numbers are the amount of atoms of each substance in the compound, and you multiply it by the molar mass of the element. And that's how you calculate molar mass of compounds. If you have any questions, leave a comment. And if you have any recommendations for more lessons for me to do, please comment as well.